In this lecture, we'll discuss about setup time, hold time, metastability, clock jitter, clock skew, and duty cycle. First, we'll see about setup time. This setup time is the minimum time that data inputs should be stable before applying clock edge. And the hold time also the minimum time that data inputs should be stable after applying clock edge. Okay, so for sequential circuits like flip-flops, we apply data inputs and control input like clock. Okay, so whatever the data we are applying, that data should be stable before the clock edge and after the clock edge for a certain minimum duration of time. So then only that circuit can take the input properly, then only it can produce output properly according to the input. If it is not taken properly, it means if we are not maintaining some minimum time before the clock edge or after the clock edge, it means if we violating setup and hold time both are any one, then circuit may not take input properly, so it may not produce output properly. That uncertain output is called metastable output. We represent that as X. Okay. Now coming to clock jitter. So we know clock edges will occur. So we expect the clock edge at certain time. Because of this jitter, that clock edge may occur before the expected time or after the expected time. Okay, this deviation of occurrence of clock edge with respect to expected time is called clock jitter. It will measure in the percentage, so that based on that percentage how much deviation is happening we can understand, so that we can solve that jitter. Okay, then coming to clock skew. Suppose there is a register, it contains different flip-flops. We are giving common clock to all the flip-flops of that register, so that common clock may reach to the each flip-flop of the register at different times. That deviation is called clock skew. And coming to the duty cycle, suppose if we take a clock cycle, it can contain on duration, off duration. Okay, so the total duration of on time divided by total duration of the pulse will give the duty cycle. It is also measured in the percentage. Okay, so the duty cycle is the percentage of on duration in the total clock cycle. Suppose if we say the duty cycle is 50%, then on duration is 50, then remaining duration 50% will become the off duration. So here the duty cycle is 50% because the on duration is 50% in the whole duration of the clock pulse. Okay, then in that case it will become a symmetric clock signal. Suppose if I say the duty cycle 30%, out of 100% of the signal duration, only for 30% the signal is high, remaining 70% the signal is low. Okay, this is about duty cycle.